So this is going to be a totally different type of talk. I'm going to talk about how to run VNFs on unmanned vehicles, which I don't think anyone else done before. So just about us, because we are not a big company like all of those there. We are a small research lab from Glasgow, University of Glasgow. It's in Scotland. And in the background, you see that picture you might be familiar with. It's from where the Harry Potter films were shot, and that's our university. I used to be a PhD student. I just submitted, so hopefully done soon. But basically, we have a small lab. You see the numbers there. There are a couple of projects with bigger companies. SD and NFV is one of the topics, one of the main topics that we're doing. I'm not going to spend too much time on this. I guess for the last 3 days, everyone was talking about the same. There are a lot of devices that we need to support if we're talking about as a network operator. We have a lot of mobile and IoT devices that are coming up. And actually, we are focusing on those devices and how to support the network requirements of those mobile IoT devices. There are different classifications and different numbers. Hundreds of different surveys estimating billions of devices. So I guess there are also a lot of things that we could consider as researchers. We are looking for, from all of these context-aware services, reliability, high bandwidth, user-specific services, we focus on the low latency connectivity. And some example services we are looking at are content caches that need to be close to you, DDoS mitigation modules, and so on. So our research project, this Glasgow Network Function project, basically marries two things, NFV and mobile edge computing. These are also kind of very popular topics right now. But what we saw that for NFV, basically it lacks latency optimal orchestration, and it doesn't allow you to run services at the network edge or at unmanned resource-constrained devices. It's mainly designed for data centers and proper servers. And then edge computing itself is on a different name, fog computing. It's more just a kind of an idea of having some computing resources at the edge and using them. So basically, we're bringing these two together. And we have various publications where we kind of advocate this edge NFV architecture. And on previous NFV SDN congresses, I've been talking about this, so if you've been attending, you might have heard this before. It's basically the idea is that instead of running all of these VNFs at the core of the network in an internal data center, we can run it on a low-cost home router. This is a TP-Link router. We actually did it, so we had an OpenWRT modified TP-Link router. You can run it on an enterprise edge servers, IoT gateways that some companies started to produce like Dell, or we can also push these VNFs to the cloud. The question is, how do you do that? Obviously with containers. Containers run on any device. They do not require any virtualization support. The only thing required is a Linux operating system and a virtual switch, let's say, and then basically all of these containers run some sort of software that implement the network function. It's a bit different, of course, for security and isolation perspective, but it has a lot of advantages of running multiple, even hundreds of small container network functions on a single host. Instead of only just a dozen. Runs everywhere. Yeah, it's very fast to create and stop it, so you can imagine in scenarios where user moves between edge devices and we can quickly recreate the new network functions in the next edge device. This is one of the things we were doing with the GNF platform. This is how it looks like. This has been implemented, and there's source code also on GitHub, and more importantly, there are quite a lot of research demos on SIGCOMM and papers at Infocom, if you're familiar with these conferences. The idea is that any compute device can be used as an underlying, almost any device can be used. So this is what we focused on, the home environment. It's kind of pushing a little bit the limit of the devices. And there are different types of software implemented. In this GNF manager, we just published a paper which is about the latency optimal allocation. So it's an optimization. It's been published to find the best latency optimal location for the network function when it's requested by the user. And we take into account the topology, some network parameters across the network, and the physical location of the user, let's say. That's the latest addition to the GNF platform. There's a general paper, of course, about the architecture. Okay, so this was GNF, and GNF can run network functions on edge devices, even in the cloud. We ran, here we have these 3 logos. Here we actually ran these container network functions in Azure, Amazon EC2, and Google Compute Engine, and then we compared also a lot of performance characteristics in terms of how they perform and how does the network support network function virtualization. So think about IP forwarding, transparent for how to implement a transparent forwarding through a VM, and inside the VM there's our little container, and so on. So our new idea is, this is a research project, so this is just starting up, is using a platform called ROFI. And ROFI is a European project called Road, Air, Water-Based Future Internet Experimentation. And it basically focuses on exploiting all these IoT/unmanned robots and moving vehicles for basically running some sort of computation and managing network between them. So there are a lot of challenges when you start doing these things. For example, we put a few here: securing data transmission between these vehicles, to detect if a sensor is faulty, because think about a lot of cheap sensors, for example, deployed in a wide area. There's a lot of moving of the devices, so again, roaming type of functionality has to be implemented or supported if you manage a network between all these devices. But also there are a lot of opportunities. For example, if you run some sort of functionality on these devices itself, then they are close to other IoT devices, and therefore giving you this low latency benefit, and you can aggregate data from nearby IoT devices. So we have this low latency benefit if we implement functionalities between all these. Of course, you can experiment with peer-to-peer ad hoc networking, so devices can connect to each other with different protocols, all low energy Bluetooth and Zigbee, and there are a lot of new protocols that are especially designed for this machine-to-machine communication. Also, a lot of devices have pretty advanced hardware. So, for example, you could run, for example, a 500 megahertz CPU and half gigabytes of RAM. You can run a few container network functions or some sensor aggregation components, for instance. This is the project itself, and these are devices that are part of this platform. So these are part of this ROFI platform, and they generally have a Raspberry Pi or similar device. They run Linux, and they have different communication between each of them, or they can even communicate. For example, this boat could communicate with, I guess, this boat. Yes, we done that works. But it's usually Wi-Fi or radio communication, or between devices you could use Bluetooth or other protocols, or you can extend the device. So this is a big platform that just, if you're an experimenter on this platform, gives you all of these devices to use. And we have a project on this platform. This is the GNFUV, so it's Glasgow Network Functions on unmanned vehicles. and it's about it's a new project, and it's about to investigate running these network functions on all of these devices, and see if we could, for instance, use them to have this kind of security functionality between these devices implemented, or understand the networking parameters better that could then influence the ad hoc network between these devices, such as. Yes, it uses the GNF, the same platform, so the container network functions that we had before. And it's just put 2 use cases that we were thinking about, and if you have any ideas, we're happy to take more. So one of the things is some sort of security functionality deployed between these devices. So for example, if you imagine a lot of sensor nodes, and some of them could be compromised with, for example, the Mirai malware that took down half of the internet last year. The question is, can we just put a DDoS mitigation VNF to a nearby, close by device and route traffic through it? Or if the device itself allows the same sensor node, can we put a mitigation virtual network function? For example, just think about a firewall, very simple firewall that blocks traffic based on the signature of this Mirai malware. Can we do that? And then how could this solve this increased traffic? So basically, what we want to solve is, for all of these DDoS attacks, there's an increased traffic for the provider, and we want to kill this and stop the traffic as close as possible to the source in order to save all the unnecessary utilization of the network. And another thing to consider is basically just simply processing information in a distributed manner. So even you can have a distributed NFV infrastructure where VNFs can talk to each other, running on those devices. Both of these, we have started experimentation for both of these, and these are pictures we've taken approximately 3 weeks ago. The testbed is in Athens, so we basically went there and we put our own battery-powered Raspberry Pis to these boats, and they were able to communicate with each other. And basically what we created is with GNF, we were able to create different sensor readers and sensor aggregators, and orchestrate them in a way that, for instance, when one boat went too far away from the others, then it got automatically excluded from the network, and then all these VNF modules that were here were moved to the other bunch. Results to come on this, and as I said, this is a very early work. But I guess I kind of told you the high-level idea, and some specifics are still to be figured out. But in general, to summarize, we have a platform, the Glasgow Network Functions. It's a container-based NFV platform, and we're trying to investigate if we could run them on these moving IoT kind of unmanned vehicles, and optimize some networking parameters, or target DDoS attacks between them, just by running some small container network functions, and basically managing the whole network between these devices, these publications. And with that, I would like to thank you, and everything I've been talking about and even more details are on our website if you are interested. Thanks very much.
So are there any questions for Richard? So 2 things. One is what sort of wireless communication are you using? I mean, have you guys made a choice between, let's say, Wi-Fi or a cell-based communication? The examples that you showed, near the ocean and all, what communication was used?
So it depends. It depends on the actual device, because in this whole project there are research projects and there are vendors who created these devices. These are completely custom and you cannot just buy them. So some of them are wireless, and when we experimented, it was wireless connectivity. But as I said, there is a way to do some sort of peer-to-peer connection between the devices. But some devices, I know, they are radio-based.
And then it seemed to me that the DDoS is just an example of distributed processing, is it not? You had two use cases.
Yeah.
But one is kind of consumed, one is subsumed by the other, right?
Yes. Okay. Yeah.
All right. Any other final questions or final thoughts before we close off this session and the last session of the conference? If not, I would like to thank David.